There we go. That sound means it's actually working. First of all, thank you all for being here this afternoon. We know it's busy. We know SF traffic is the stuff of legends sometimes, so thank you for making your way out here. Also, thank you to the 4 people who sat in the first 2 rows. You're my favorites. The rest of you, just so you know, we have plenty of content to go over, yes, but we would love to make this as interactive as possible. So if you have proactive questions to ask us during, please never feel like that's the wrong time to ask. Just ask. And we actually have a couple home minis to give out to those who are the first to participate. No pressure, but there's a slight incentive. 30 whole bucks, got to do something. Exactly. I see the hands are going up immediately. Really quick, my name is Spencer Paul. I head up our US operations for Do It International, and we're going to have plenty of content mostly related to Kubernetes, Kubeflow, a number of other products mentioned. But like I said, as we're going through this, it's easy to just kind of sink into slides. We will do our best not to let that happen, but please feel free to ask any questions you have in the meantime. First of all, I know we're in the Google building, and you all know Google pretty well, but you probably don't know Do It International, so much so that most people say Do IT. Just so we're clear, it's Do It. If you never do that correctly, you will join many customers of ours who never do it correctly, so don't worry about it. But specifically, who are we? We have a global headquarters in Tel Aviv, Israel. You'll notice the accents from a couple of our presenters. It's not a joke. It's actually very real. And that's where actually the start of the company was. As of about 1.5 years ago, we expanded operations to the United States and have since opened offices in Austin, New York, Santa Clara, Santa Monica, with many more coming. But this, to be clear, is the nexus of where these types of conversations happen first. You all know because you all live in the same similar area. And we intend to find our way, our match to the right customers by making sure we invest in those places. Beyond the who is Do It pitch is also what is a Google partner, right? There are partners that make their business model off of being large-scale SIs. Those exist. They are not us. We are kind of a unique hybrid. We are a managed service provider with a very unique business model that avoids service contracts whenever possible. So in the time we've had US operations, we don't actually ever charge customers for the work that we do with them. Our intention is to really make sure that we're giving engineer-to-engineer support because we candidly think that's the only thing that's really useful in a large-scale cloud evaluation. Beyond that, you'll also see some Amazon and Azure logos out there. That is intentional. We do offer multi-cloud engineering across platforms. Clearly, when it comes to Kubernetes management, there are definite advantages of Google, but the intention of today's conversation is not to brainwash you into moving to GKE tomorrow, but to give you a realistic sense of what differences, trade-offs, and advantages there are using Google Cloud Platform. We've been Partner of the Year before. We've been Partner of the Year many times. That's not really important, just there for credibility's sake. So beyond that, we are especially unique among other partners because apart from finding technically complex challenges and helping customers solve them, we also spend a specific amount of time giving back to the open source community. The platform view that you see on the left labeled Reoptimize, if you've ever endured or experienced the GCP billing console, you probably notice a few shortcomings. Do It recognized massive gaps in that platform long ago and created Reoptimize to fill them. So features like being able to tell you exactly what you should commit to for a committed use discount, universally applicable and not available without this kind of tooling. So we've launched it. We've made it available for all of our customers, again, for free. Beyond that, one of our presenters today is responsible for the BigQuery Grafana connector that actually did not exist up until a couple months ago in GA. And Aviv, our first presenter, is actually the creator of that plugin, as well as numerous other open source tooling to extend what already exists in Google and make it more useful for our customers. We're not here to talk about that specifically. So for the rest of this, I want to make sure we really focus on not giving you the sales pitch, but giving you a sense of what is possible. I know there's some folks on VC. If you could mute yourself, just so there isn't background noise. Apart from that, we have a unique value prop in that, as I said, we don't charge for services, but we have a unique focus on cost optimization for cloud. Regardless of what cloud you use, regardless of how mature your experience on any public cloud is, that is a consistent concern we know customers care about and a universal linking piece to start that conversation off. Migrate to Google Cloud in 21 days. That is a marketing pitch. We are not telling you that every one of you can indeed move to Google Cloud in 21 days, but if you want to explore that possibility, we've done it before, and we would love to explore what's feasible for the right customer. Finally, I'll get out of your way and actually turn it over to the real stars of today's show. With our customer base involved, almost every single logo you'll see on this screen has done some massive testing and battle-proof testing of Kubernetes, of GKE, and comparing it across clouds. So while we don't have an intention of just giving you one-sided information, we do want to bring expertise we've had across clouds to you as well. And with that, I will turn it over to our presenter, Aviv.
Hi. This one. Try to get this one also. And just use this one.
I'll show this one also.
So my name is Aviv. I've been working in the software industry for about 25 years, mostly VP engineering, CTO positions. I joined to do it a little bit over 2 years ago, doing a lot of architecture reviews, open source contribution, etc. I'm also a GD on the cloud. That's about me. So feel free to interrupt me. I've got two partners in crime here, Ami and David, that have better knowledge than myself about AWS. So if you have more AWS specific questions, they probably can answer better than me. So everything in Google is running in containers. No matter if you do search, use Gmail, running a VM, file system, everything is running in containers. Google recognized it a few years ago and starting using it. The first project was Borg, which was internal project by Google. And they launch about 4 billion containers per week, which translates into about 500 million containers per day, which it's quite a large number. They were the first in market to use it as internally, and 15 years ago. And later on, they started moving it to more normal processor. They started with, if anyone familiar with C groups, and later on namespaces, etc. And LXC, namespaces when Docker was launched. And around 6-7 years ago, they started to move Borg, which was the internal name, into open source. And ever since, a lot of development. The latest one are the Istio and Knative and gvisor, which at least gvisor is, we don't have any other tool like it anywhere else. gvisor is the option to run a container, very isolated container. It's kernel mode runtime, user mode kernel, and you can run very securely over them. AWS joined the container revolution a little bit later as a service, only about a year ago. And they are moving fast, a lot of new features. Even in my presentation, there are things that when I started the presentation, they were in beta, and now they're available, like Windows containers. And like everything AWS is doing, it's very tightly integrated with the rest of AWS services. If on the later slides, we can see that on that topic, Amazon got better integration with more services on their part than Google. So how many people are familiar with Kubernetes, run it in production, etc.? Okay, so I'll just run over it. There's kube control, which is the controlling, let's say, program that speaks to the API server and do all the changes. It interact with the master. And then you've got nodes, you've got node pools that contain many nodes. And in front of that load balancer, the user interact with the load balancer. On AWS, basically you've got your EC2 instances that are acting as nodes inside your cluster, inside your VPC. And on Google, it's almost the same. Networking, it's much easier, and all pods got IPs and IP aliases, part of the DNS that's running on the cluster. How many people are familiar with the Google VPC versus AWS VPC? Okay, so when you've got a project or got a VPC in Amazon, it's only for one region. In Google, an entire project is a VPC, meaning you can have your instances or your projects running all over the world. You don't need to do VPC peering or anything else because one project contains all of your machines. So you can do different projects and have shared VPC between them. So you have more control, more security, separations of roles. You can share common resources, and very important, you can have a very granular billing control. You know who is paying for what. There's a new feature that is currently in beta, which basically gives you an ingress or an entry point into your Kubernetes services on different clusters. You can have more than one cluster running across the world and one entry point, and the Google global load balancer will take care of that and will direct the traffic to the one that's close to the user. This is still in beta. It's looking good for now. Very promising.
Question.
Yeah.
That on the global load balancer, is that a normal Kubernetes?
It will be part of it. It's a normal Kubernetes ingress, yeah. You won't need to do anything specific in order to enable. Okay.
Just want to make sure we. Sorry, continue.
Ooh, I wasn't even thinking of that.
Yeah. Okay, so interaction with the cluster. So in Google, you've got the gcloud command for create and maintain a cluster. gcloud is maintained by Google. On AWS, you've got EKS control, which is an open source tool, which is not maintained by Amazon. So your mileage might vary, and not necessarily that every feature will be there, and the response time is a little bit slower. But basically, it's give you almost the same interface in running. Let's launch two clusters, one in AWS and one in Google.
That's the AWS.
Yeah, we'll give it a head start. Oops. Oh, okay. Sorry. Great, yeah, I know. Sticky figures. Correct? No? CRT? Okay. So in a few minutes, we'll go back here. From my experience, bringing up a cluster in Google, it takes about 2 to 3 minutes. On AWS, it's 15 minutes. So not every day you're creating a cluster, but if you're relying on automation and you need to bring up and down clusters, there's a big advantage here. So integration with the cloud services that are there, you can see that each one of the offerings, the GKE and the EKS, give you almost the same interaction with services, because basically on those two systems, on Google you've got the managed instance group, and on AWS you've got the auto-scaling groups. That basically you've got a bunch of VM that running your Kubernetes cluster behind the scenes. So whenever you can do from a VM, you probably can do it also from a cluster. Istio is part of the installation in Google now. In Amazon, not yet.
That was another question.
Second one, yeah. It's Spencer. Give him one as well. Yeah.
There are multiple clouds. There are only not two clouds. There are a lot of clouds.
I know there's also a,
Why is that you're picking up on it?
because those are the two that are leading right now.
Oh, I see.
Microsoft also got the AKS, which is Azure Kubernetes Service, but I think it is a way to go.
What about the Alibaba cloud?
I'm not familiar with Alibaba Cloud, so I wouldn't feel comfortable about talking there. Something
Okay.
that and we are as a do-it not working with Alibaba Cloud, we're working with Amazon, Google, and Azure, so this is more relevant for us.
The cloud is like it moves from, doesn't have any territorial boundaries. Cloud is like, that's a conceptual idea.
Yeah.
Because things move from cloud. So I think all the clouds are connected at some level.
At some level, yes. And Google got a nice feature which is called GK on-prem. Or I think now they rebranded this as Anthos, sorry, which basically allows you to run a Kubernetes cluster on-prem or somewhere else. I'll speak about it later, and manage it like it was running on Google. And this is a very nice feature, especially if you have your own data center and want to start migrating to the cloud or some of the workloads. You can use the same interface which Google has to manage your own data center. And I think it's currently in beta or in alpha, so correct me if I'm wrong, but you can start running, you will be able soon to start running GK on-prem or Anthos on AWS. If you have a bare metal machine there, you'll be able to run GK there. I think this is a big advantage if you're multi-cloud, and more, we see more and more companies that are multi-cloud, and starting at AWS, moving some workload to Google, or for various reasons wants to be on more than one cloud. And the fact that you can manage all of your cluster with a single interface, it's a big advantage. So in terms of deployment, basically they are both on par. One thing that Google have it also with Anthos, it's not perfect. I think it's still in beta. It's the automatic VM to container migration. It's not perfect. It's lift and shift, and basically it takes your VM and move them to a cluster. It's a start, but you've got a lot of legacy workload and want to start moving to the cloud. It will make your life easier. And the rest of the things, they're basically almost the same, and not much of a difference. But this is, at least from my opinion, its advantage. Google provides you a little bit more visibility inside what happens. You've got a view inside the container logs, on-premise Kubernetes management, which I managed before, and integrated development environment. There's a product by Google, I think it was released about next. It's called it's Cloud Go or something like that. No, not Cloud Run. It's an extension for various programming environment, for IDEs, for JetBrains IDEs, for VS Codes, for Vim, etc. That enable you to debug and deploy your Kubernetes cluster from inside your IDE. It make your life a little bit easier, and it's getting better actually every day. When I started with it, it was a little bit rough around the edges and functionality was not there, but it's moving very, very, very fast. Service discovery, Amazon got it, Google doesn't have. Shared VPC cluster, it's a big advantage of the Google, and usage monitoring. This is not correct. Amazon got it already in the GA, I think about a month ago, so they're a little bit ahead of Google, running the Windows containers. Yes.
How would you do service discovery in GK then?
There isn't currently. You have to do it yourself.
So you like build it yourself then?
Or use console or whatever. Yeah.
Okay.
They are planning for console for GKA, but
Okay.
not vice versa.
All right.
Okay, serverless container deployment. In AWS, you can use Fargate. In Google, you can use Cloud Run, and I'll talk a little bit about Cloud Run at the end of my talk. The rest of it is basically almost the same. SLA you've got SLA in Google, but from the documentation, it seems that Google is not guaranteeing anything about the SLA. In Google, you can have a cluster with 5,000 machines. Nothing is specified in the AWS documentation, so I guess the limitation might be of the number of VMs, the EC2 VMs that you can bring up in a certain zone. But I don't know, nothing in the documentation about there. At Google, as I said, it's 5,000 machines per cluster.
Just to touch on the SLA part, there's two versions of GKE. So you've got the regular GKE and you've got GKE Advanced. And GKE Advanced is backed by SLA, I think it's 99.95. So that's a little bit more on that.
So node upgrades and backups are part of both cloud providers. Multi-zone clusters. Better? I'm used to speaking with my hands, so it might be a little bit problematic, but I'll give it a try. So multi-zone I think it's a killer feature because you can have the same project, few clusters, both for high availability and for performance and better service to customers. And since that GKE supports multiple, this is something that I think we missed in previous slides or next slide. You can have multiple nodes pool, GKE and AWS. But in GKE, you can have different sizes of machines in your node pools. So for example, if you've got a region or a geographical area where the type of work is create less load than the other area, you can create the same clusters, different node pools, and assign the workloads on those node pools. So you give you a lot of flexibility, not just in terms of performance and availability, but also from terms of costs. And of course, all nodes can be preemptible nodes, which will save you another 80% or so. Again, both cloud provider will give you pretty much the same set of security. Sandboxing gvisor was announced last year, and Google Next. When it started, it suffered with a lot of performance issue, as you would expect. But things are getting better, and for some workload that you need a very, very isolated environment, this is currently the only solution that it's out there. Okay, Cloud Run. Anyone familiar with Cloud Run? So Cloud Run is basically Google serverless solution. It's built upon Knative and Istio, a version of Knative, I would say, with some tweaks and tricks. And it allows you to run any workload that you can put in a container, no matter in which language you wrote it, anywhere. And Cloud Run comes in two flavors. It comes with the fully managed service. So basically, you just need to have a container, put it into Cloud Run, either from the command line or from the console, and run it. Or you can use the same interface and specify your own cluster. And it scales to 0. So if you don't have any requests, you're not paying anything. We got some downsides. Connectivity from the managed Cloud Run it's not ready for all of Google services. You can access some of the services from the managed environment, but not all of them. And you've got a limitation of 10 minutes processing time per request on your own cluster, or 15 minutes on the managed one. Meaning if a request takes more than 10 to 15 minutes, it will be dropped. I wrote a blog post a while ago, I think months ago, about how you can bypass it. It's a hack, but if you really need some long running task, you can do it. It looks like, at least from my point of view, that Cloud Function and App Engine, this is my opinion, it's not Google, so do whatever with it. Everything will converge into Cloud Run. There's no need to have 3 environments that basically do the same. So App Engine and Cloud Function will go inside Cloud Run, and that's it. And this is the future. It's really easy to use with it, to work with it. The interface is good. The performance are okay, getting better. Cold start issues are starting to resolve. There's a balance between cold start and scale to 0, and someone need to figure out what's more important, because some people want scale to 0, some people want slow, fast startup. Yeah. If it's running inside your cluster, yes. If it's managed, it's part of a project. And of course, you can give it a service account credentials that enable it to connect to other projects. You can define, if you want it, when you create a Cloud Run, you can define whether or not it's internal or external, and what kind of authentication do you need. I suggest everyone to just play with it. It's very nice, very easy. If you have a container, it's there, so you can run a lot of workloads. You can, and not like Cloud Function, you can have multiple endpoints in one Cloud Run, because in Function you have one endpoint. And of course, you've got file system because you're running in a Docker container. So there's a lot of things that can be done with Cloud. Yeah. That's about it. I'll be happy to answer any questions or to talk to any other topics cloud oriented.
Yeah, if anyone has a question, I'll give them the mic so everyone can hear it.
On a previous slide, there was mention of a single tenant master or multi-tenant master, and that GKE only partially supported that?
Yeah.
The single tenant cluster master was NA, and then AWS says yes.
Yes.
Could you talk to that a bit?
It's not available yet. I don't know what the plans are. Maybe someone from Google can share the library.
Question.
You explained a lot of variables between GCP and AWS. You explained a lot of slides, comparison between GCP and AWS. If you got a customer who wants to use one of the services where they're not well qualified to, to differentiate between the two, what is the criteria for all these different functions in terms of values, some of the NA, some of the partial from both sides? Give me impartial opinion.
Impartial. I'm biased towards Google. I would say it. I'm not working for Google. I work with AWS and Google. Personally, I feel more comfortable in the GCP environment. In my previous life, I ran very large workloads on AWS and some workloads on Google. I think Google has some better selling points regarding some workloads, whether it's big data, machine learning, and Kubernetes cluster, just for the reason that they've been doing that a long time. And my feeling, it's more mature product. Amazon is closing the gap, but for now, I would go with Google. Amazon tried to do it with cups and targets, all kinds of things, until a year ago they started really understand that they need to have a full offering Kubernetes. And by the way, I forgot, let's see if Okay. Google finished in about, let's see.
I have a question.
Yes.
So it's about Cloud Run.
Mhm.
So when you said serverless service, is it parallel to the AWS Lambda?
No, AWS Lambda is more parallel to Google Cloud Functions, which basically you are constrained by your runtime. Not all languages supported, not all libraries are supported, and you have a function, just one function. In Cloud Run, you have a container, which it's basically you can run an entire application. You can write it in whichever language you want, use what libraries that you want, and it can have multiple entry points in one container.
Okay, so platform is different, but
It's
both
a
are
little bit more
serverless.
like Fargate.
Okay, got it.
Okay.
Yeah.
So Google, it took about 3.5 minutes. This is, we started 1746 and it took 16 minutes. So almost 4 times faster than Google. Any more questions?
What do you think? What exactly makes AWS store very cluster resting?
I don't know. It was worse.
Start an instance.
Yeah.
It's a matter of
Yeah.
10 seconds.
So I'm saying is going back to the VM instances. Basically, when you create a node, you create a bunch of VM instances. So if you try to create a VM instance in Google, it will take between 30 seconds to a minute. In Amazon, 2.5, 3 minutes, give or take. Yeah. So on that, a lot of things are built up.
Yeah, the networking, all this things.
Not all the time you need that fast timing, but if you need it.
So since you work with both EKS and GK customers, when you see folks that are multi-cloud, what is the most common compelling event that makes them choose one or the other that you find, or chooses GKE over, or GCP over?
It's more mature, faster times, more flexible. It's a mature product. Amazon also. So you're paying at Amazon for the control plane, which is I think 20 cents per hour, etc. But I heard rumors that they're probably going to drop this as well. So auto-scale. So you've got pods auto-scaling, which you have in boats, and you've got node auto-scaling, which I think that Amazon started to support it, but I know that Google is working with it, and it's working amazingly. You just need to define your metrics, and nodes will be added and removed from your cluster. And of course, you can decide that those nodes are preemptible and will be cheaper. Yes.
What about, so you mentioned multi-zone clusters. Well, that's great. What about the regional? Because there was the federated.
It's the same.
But get dropped. But is there? I know that right now I haven't seen anything that allows me to have a cluster that spans multiple regions within US Central 1A.
It's not the same cluster, different clusters.
Yeah, that would be different clusters. So then at that point, what do you guys typically do? I mean, you can use Istio and do a service mesh between the two.
So Google used to have it. It's called federated clusters.
That hasn't been dropped.
It's been dropped because it wasn't working very good.
Yeah, exactly.
So they moved to the ingress control.
So in your experience, you guys are going
Yes.
towards
Multiple clusters, but with one entry point with the global load balancer. It's easier to manage. The clusters are agnostic to each other. Okay, thank you. God, the show is yours.
Hey everyone, I'm Mr. Michelle. It'll take me just a minute or so to connect. But in the meanwhile, I think it'll be nice to know who am I talking to. How many people here are DevOps, Ops people? How many are related to machine learning in any way? Okay, so we have a few. Data scientists. All right, developers. Okay, so we have a very mixed audience today. It's good. Just gonna connect to the Hangouts. Let's see if I'm the one presenting. Yeah, cool, works. There we go. Cool. So my name is Gad, and I lead the machine learning team here at Do It. And I'm here to talk about Kubeflow and how to do machine learning on Kubernetes, and whether it really helps or it's just a little bit of overhead. Because I know machine learning people don't really like to complicate things with a lot of technology. Like we kind of love to work on our MacBooks, with our Jupyter notebooks. So can Kubernetes really help us do anything that is related to machine learning? So we're going to have 4 topics for today. The first thing is we're going to talk about what is the difference between having a theoretical solution to a problem using machine learning and actually bring it to production. And later we're going to talk about what is Kubeflow and how is it going to help us do this. And the third part would be are you going to do this using Kubeflow pipelines? And then we're going to talk about some other cool things that you have in Kubeflow. So let's start by talking about the difference between theory and business impact in machine learning. So I think that the machine learning people here would probably know this, but machine learning has been a very hot buzzword for the last years. But it's not such a new thing, actually. You can attribute the first machine learning application to a guy named Arthur Samuel, who worked in IBM in 1947. And he developed this application that could play checkers against humans and could actually beat them very, very well. And it was not programmed to do each and every step or each and every move, but rather it improved by accumulating experience. And this is considered the first machine learning application that was ever developed. And it was developed in 1947, but I guess that if you think about it, I couldn't find an actual reference to when was the first time that people could play checkers against computer. But I guess that the widespread checkers game was only available after the arrival of the internet or the .com. So it took quite a long time between having a theoretical solution to how to make computers play against human and beat them in checkers, and having the wide public being able to do that, actually. Because you had other blocking steps in the way, for example, the lack of internet. Another thing and this is a slide that I just copy-pasted from a Googler. He tries to show how well does Google does translation. And his Korean is putting here some text in Korean, and is using translation from, I think, from English to Korean or vice versa. And it's showing that it does phenomenal, it brings phenomenal results, compatible with experts translation. And he mentions that now Google Translate is available in general availability since September 27, 2016. Now that may sound impressive, but to people who know machine learning, it was well known a few years before that the only way to achieve very high standard translation results was to use recurrent neural networks. So why did it take for the most advanced technological company in the world a few years to bring this very, very obvious solution that RNNs can do translation to production? So maybe when you're trying to search images for AI applications, you find a lot of slides, a lot of great ideas. But perhaps when you try to look for applying AI, it should more look like this, right? A lot of companies are the dreams are big, but the reality is kind of shady. And when I go to customers, and this is like a secret that I shouldn't be telling, and I have some customers that are doing very successful machine learning deployment to production. Sometimes they really rely on this single person that is machine learning hero, superhero, and that is a person that does the research and the data analytics and the development. And this guy also kind of a girl, she kind of knows how to do the ops and to talk to the managers, and she really well understands the product. And I think like the number of companies that have really good machine learning applications running in production is kind of correlated to the number of people to the number of machine learning superheroes in the world. So, and this is obviously cannot continue. But you should be very relaxed about it, because if you think about software development, it was just the same, right? If you think about the 30s, you'd have to be Alan Turing in order to develop machine learning applications, software applications, right? In order to write code, you had to be as genius as Alan Turing. And then if you see like the I think 2018 movie Hidden Figures, you'd have to be a very technical person with a very good background in math in order to know how to operate in IBM and to write code. But then at the .com area, we started to see more higher level languages, programming languages that enabled more people to actually create software. And nowadays, you can actually create websites without writing a single word, a single line of code, right? So the abstraction of tools really helps us simplify the process of creating software. And for machine learning, you can think of TensorFlow as doing this process, right? If you started working in machine learning in 2012, you'd have to know a lot about the math and the derivatives and the backpropagation. But really, if you're using TensorFlow today, you don't really have to know what is the derivative of a sigmoid, right? You can just say you want to have a neural network with 5 layers and use the TensorFlow syntax in order to create your network. So TensorFlow is really part of the solution. But it kind of portrays the situation as if the ML code is like the bulk part of developing machine learning applications, right? You would talk about, when I'm talking about machine learning applications, you would talk about if I'm using convnets or if I'm using recurrent networks, if I use dense networks, am I even using XGBoost, how many layers I'm going to have, how many filters I'm going to have. And it sounds like it's like the bulk part, but really, you can write your machine learning code in just a few hours. And then when you want to bring it to production, it more looks like this, right? You have to worry about data verification and the serving infrastructure and like your data validation and pre-processing and a lot of different and a lot of big workloads that you have to do besides your machine learning code. So Kubeflow is an open source project that is supposed to help us overcome many of these tasks that are not solved by TensorFlow. The name implies that it's TensorFlow and Kubernetes together, but it's not only TensorFlow. Like TensorFlow is a representative of machine learning. It's actually a set of several very well-known libraries that are very well used in machine learning today for serving, for preprocessing, for writing models, for training models, for distributing the training. Just stringing them all together into one package that enables you to do all of your machine learning development in one place. So who's going to use Kubeflow? It's going to be used by data scientists. It's going to be used by the ML researchers. It's going to be used by the analysts, the developers, the DevOps people. Basically, everyone who's involved in the development of machine learning pipelines is going to be able to use Kubeflow and leverage it to some extent. What is it? So it's a portable production-grade machine learning on Kubernetes. It's currently in alpha. So don't expect that it would be perfect right now. It's an open source project. But the expectations for it is to be beta by the end of this year. And it's really, really progressing so fast. I've been given this talk, like it's I think my third time that I've given this talk. or fourth, like the 3 previous times were in Hebrew, so it's kind of different for me right now. But every time that I'm like rehearsing the slides, I make sure that the things I'm saying are really relevant, because everything is like changing super fast. So if you want to work on Kubeflow, you should really make sure that you're up to date with the latest version, and you're really taking advantage of all of the new features that are coming on like monthly basis or weekly basis. So why do we even need Kubeflow? So what's the idea? You can also think about you can also compare it to developing web services in the past. A lot of companies used to have their own web service code, right? And now with Lambda functions or cloud functions, you no longer need that, or you can like share a lot of these way to serve your logic. And what makes your company unique is not the way you serve it, but rather the logic itself. So in machine learning, it's kind of the same, right? You have your own model, you have your data. So what's make your company unique is your data, your business implementation of the problem. But the way you serve the models, the way you train your models, is really something that most companies can just share between them. And this is what makes it very, very reasonable to make it an open source project. So key concept that we're going to have in Kubeflow. First of all, portability. We're going to have an ability to take our production system, and scale it and move it between clouds. Or if I'm starting to work on my MacBook and then I want to move to the cloud, I want to have the same experience. So once I deploy my Kubernetes anywhere and I deploy Kubeflow on this Kubernetes cluster, it's not going to make difference to me if I'm running on AWS or on Google, or if I'm running on-prem. Another thing that is extremely important when you talk about machine learning is scalability. Not only in the serving, because once I have the model deployed, I can like go from 0 to millions of requests per minute, but also in training. So sometimes I want to train my model on a very small sample of data, but then when I see that I get good results, I want to train it in scale on like a lot of data. So scalability is extremely important, and I'll be able to achieve that by using Kubeflow. Composability. To the people who actually develop machine learning applications, they know that they have like these parts of their code that can really be shared between different models that they're building or different projects that they've been working on, but they don't really always usually reuse their code. And you can think of maybe we can create some components that we can compose later in order to create these pipelines, and we don't have to we'll be able to reuse our code. Another key concept that we're going to have in Kubeflow is a full ML lifecycle. We're going to create this platform that is supporting us from the discovery of the data, from the pre-processing to the training and the deployment of the model. And it's going to support GPUs and TPUs that are specifically used for, or very commonly used for machine learning. So how are you going to achieve that? So if you're running on, on Google, you might be using a lot of services that enable you to do machine learning, right? You can use the compute instances and the AI platform to do your training, and perhaps cloud GPUs to do training, or you're using BigQuery to do the pre-processing. So you'll still be able to use all of these services, but we're going to put a layer on top of that, and this layer is going to be Kubernetes. And we're going to have a cluster that is going to allocate the resources for us. So if you want a compute engine, for example, we're not going to reference the VM itself, but rather we're going to let Kubernetes allocate us this compute engine with a GPU. And on top of this Kubernetes, we're going to have a lot of pods that are actually very standard machine learning tools that we all know and love, like Jupyter Notebooks, or machine learning pipelines, or hyperparameter tuning, or TensorFlow. So Kubeflow is not really inventing anything, but rather combining very well-known tools into one singular seamless platform. So let me just go and show you my console and see what is this Kubeflow that I'm talking about. And I'm going to steal this gentleman's water. So when you enter Kubeflow, what you're going to see is like this new UI. It changes. It changed like I think 3 months ago. You can see here the link to the documentation. You can see here the pipelines. And I'm going to talk about what are pipelines, and I'm going to demonstrate how to work with them. You can see here that you can build network servers. So if I want to have a Jupyter notebook, I'm a data scientist, and this is something that we see in lots of companies. Notebook servers are not always used. Like you want to do some research, want to do some testing on a new model. So you need a server ad hoc. So you can launch your own notebook server, for example. I need to select a namespace. And I'll launch it. And let's see what happens in the background. So if I go here to my console, I'll see that I have a Kubernetes cluster running, a GKE cluster running. And the workloads that it's running is actually a lot of workloads that are related to machine learning. For example, here you would see the Jupyter web app that allows me to run Jupyter notebooks on my cluster. So I can allocate resources dynamically. So I don't have to have a machine up and running all the time. I can use the cluster to auto scale. And when I need when one data scientist is working on a Jupyter notebook, then I can allocate this resource. And if 10 people want to work at the moment, then Kubernetes will automatically auto scale and allocate resources. And you're going to see this under the node pools here that are currently have 3 nodes. But if I will try to launch many more servers, I could scale up very easily and seamlessly. And that is very natural to whoever worked with Kubernetes.
Good. Quick question. Do the notebooks sync with the GitHub, GitLab, so that you can share code?
So it's basically, you don't feel the difference between running notebooks on Kubernetes and on VM. And you have the same integration that you have when running on VM. So yeah, you can set up your credentials on the server that you started and download your code from GitHub.
What about user authentication? Like user A as let's say first 3 notebooks, user B as another set, and is there a clear separation or is it free for all?
Yeah, okay, it's a very good question because it just changed in the recent version. And I actually had an issue in like 2 versions ago about this that I opened in GitHub. The way it works right now is that on GKE, you get, on Google Cloud, you get authentication using your IAP. IAM? No, IAP, I think. IAP. It's based on your IAP. And everyone who's connecting is creating his own namespace. So you can see here that when I created the cluster, I selected my namespace because I'm the only user. But you can connect to other people's namespaces and then create notebooks under these namespaces. So there is So virtually you can separate, but you cannot control. If you want to restrict, you'd have to wait for later versions. But it is a concern. There is a track for better user management. Maybe other questions?
Do you know what IAP is?
Yes.
Everyone?
It's
your Google credentials, right? So that
It's
you
your
can
Google
sign
account.
into service with your Google credentials. And a namespace for those who aren't new to Kubernetes is essentially a way that you can close off a Passover cluster with security parameters so that only certain people can have access to that.
Building on a previous question, we can companies using OLAP.
How
does that work?
Okay, so I think you're referring Colab is like the notebooks that you have for free, right?
Yeah.
So Colabs are kind of not part of, I think they're not part of Google Cloud. They're kind of more related to the docs or the slides.
Yeah.
There are some limitations in using Colab. For example, you don't know what is the resource that you're getting from Colab. It's not connected to your Google Cloud account. So it's more of like if you're trying to teach something and you want to share this notebook to your classroom and everybody can work on the same code, so that would work fine. But I think like if you think about production systems and you want to have your Colab connect to BigQuery, that would be kind of tricky to do, and you have to give credentials. So I think would be more comfortable if you're talking about production grade machine learning to work on regular notebooks running on Kubeflow or AI platform rather than on Colabs.
But that is only if you are using Kubeflow inside of Google Cloud, right? Because if your Kubeflow is completely dependent,
yeah,
it's not a problem. Right? You can have your own thing running there.
Okay, so the thing is, once your DevOps person is taking care of connecting Kubeflow to giving Kubeflow the right permissions, then it doesn't matter if it sits on-prem, and then you can give the cluster permission to access Google services. So in terms of the user experience that you're going to have, you're not going to feel anything different. You're still going to connect to this wonderful UI, and you're going to experience that like everything goes very seamlessly and fluidly. But the DevOps person is going to have like a difficult time setting up at the beginning. Yeah. Okay. So let's talk about Kubeflow pipelines. And this is like my favorite part of Kubeflow. The idea is to have end-to-end orchestration of the machine learning pipeline. And I'm going to talk about what is end-to-end orchestration. I'm going to demonstrate a few pipelines. You want to have very easy way of doing experiments, right? Because after you've written your pipeline that is made of data aggregation, data validation, some kind of pre-processing that you want to do, training and deploying, you may want to try doing this, running this pipeline with different parameters, like different networks or different hyperparameters, and see what results you get. So you want to have this ability to do easy experimentation. And I talked about composability. So I want the pipeline to be composed of different components that I can like put in together like a Lego, and like very simply build this pipeline out of these components that I'm making. So what's in the pipelines? So you're going to have a user interface. You're also going to have a way to schedule and run the pipelines. And you're going to have an SDK to run it. So let's take a look on the UI that I was talking about. And by the way, my notebook has started. It's a little slower than running notebooks on AI platform. These are a little bit faster. But it has its advantages and disadvantages that we can talk about later. And this is just the regular Jupyter notebook that we all know and love. And you can also get, I think, the lab here. Right. So let's talk about the pipelines. What you see here is a bunch of pipelines that come with the default installations. These are just part of the open source Kubeflow. And what you can see here is the first pipeline that we're going to talk about. It's called flip coin. And the idea is to check if our coin is fair. So the thing is, the first step that we're going to do is you're going to write a code that simulates flipping of the coin. And then based on the results, we're going to generate random numbers. And based on the results of the random numbers that you generated, we're going to print some outputs. And well, the colors are not very well shown on the screen, but it has different colors here and here. And the idea of the pipeline is like this. What you can see here is that you start by accessing the first component of the pipeline. And then you're going to have a condition that is going to check the output of the first component. And then based on this condition, it's going to decide whether it's going to continue to run the next components. In order to do that, you would usually have to write YAML files, but nobody likes YAML files because they kind of like make you nauseous. So there is a nice way of doing that with a domain-specific language that the Kubeflow guys are developing. And let's see what are they doing. So for example, I'm writing here a Python class that is called random number operation, random number op, that is basically inheriting from container operation. And you can see here that my image is Alpine. And Alpine is just a Docker image that is used to run bash commands. And my bash command that I'm passing in as an argument is just a Python code that generates random numbers between low and high. So I have a container here that knows how to run Python code, and it goes here. So what's going to happen when I'm going to run this pipeline, if I'm going into this condition, then it will just run this container. So this is the idea behind Kubeflow. It's running containers, and it's chaining them and it knows how to chain them. So I'll continue to the next slide. This one. What I had here is showing you that I can also write containers that the flip operation container, which creates the coin flipping, and the print container that just prints the messages. And when I want to chain these containers, so basically it's going to look like this. I'm creating a pipeline. And I'm creating a function that runs the containers that I defined, like the object that I defined. So the first thing that I'm going to run is the flip coin container operation. So it's going to create a pod of this container. And then based on the results or the outputs of the flip, it's going to decide if it's heads, then it will run random number operation. So it will run a different this container between 0 and 9. Or if it's tails, it's going to run random number operation between 10 and 19. So this is kind of a way of running tasks and based on the results, deciding what to do next. So let's see how I run this. So this is the pipeline that I showed you before. And I'm creating a run. Let's call it V2. And I'm going to choose an experiment. I'm going to talk about what is an experiment. But the experiment here is coin flipping. So my experiment is kind of to see if my coin is fair. And it's going to be a one-off. I'm not going to make it a recurring one. And you can see while I go, let's wait. Then what it would do, it would start scheduling my pods one after the other and run my pipeline. So here we start by making the coin flipping, and you can see the logs here. So the log is tails. It already finished. And it finished also the other steps. It generated a random number, and eventually it printed what I asked it to print. Okay? So what does it have to do with machine learning? So you can think about it that what I created here is actually a way of making pipelines. And instead of now writing just Alpine code with a single line of Python, I can actually create much more complicated pipelines using containers that do data aggregation and data validation and training. So I have this, for example, pipeline that is also coming with a default installation of Kubeflow that is working on the Chicago data set in order to predict whether a taxi ride is going to end up with a tip or not to the driver. So what we do here, if you can see, is that I'm starting by validating on the data, doing some pre-processing using a data flow. So actually, Kubeflow is launching a data flow work to do the pre-processing. This is kind of an interesting way because you can decide if you want to run your code on your cluster or you want to send it to an external service. Later, it does training on the cluster. And later on, it does prediction and shows me the metrics that I got. So let's see, I ran this pipeline before. So if I look at experiments, and experiments is just a way of organizing my runs, you can see that I have V1, V2, and V3. And you can see here that I ran them probably with different parameters. And this V1 was much better than V3, because here you can see the accuracy score of my run. And I can also see that this one failed. So I want to see why this one failed and this one succeeded. So I can select these and make a comparison. And you can see the hyperparameters that I ran my pipelines with. So V1 that succeeded ran with this. All of the parameters are just the same. Besides this one, V1 ran with this bucket, and V2 ran with bucket that does not exist, and that might result in an error. So that allows me to monitor not just my results of my pipelines, but also see why I got errors. And if I want to see why V3 was less good than V1, I can compare the hyperparameters and see that V3 ran for more steps. So perhaps I'm overfitting. So it's a nice way of experimenting with our pipelines and see different results. Right. So these are pipelines by Kubeflow. Very, very cool way of controlling your environment. I know that a lot of companies, well, they usually start with one person doing machine learning, right? And and he or she has their notebooks and they're running their experiments. And when they want to scale out, many times things get a little messy, right? You don't always keep track on where are all the notebooks that you were running, or which results you got for running the experiments with which parameters. So Kubeflow really helps you sort all of this together and organize your way of training machine learning pipelines. Some more cool features that you have integrated. So as I showed before, you get accuracy scores integrated within the pipelines. If you go here to the outputs of V3, you'd be able to see the ROC curve and the confusion metrics and TensorBoard and very cool things. It also integrates very well with TensorFlow Extended. And TensorFlow Extended has cool features that enables you to do data validation. So for example, you'd be able to see the distribution of your data, the distribution that your data ran on, and also model validation. So after you train, you'll be able to slice your data and your model and see which results you get for different slices of the data. And by that, I mean, for example, I can choose this feature, which is the trip start hour, which is a feature that I created for the training. And I can select one of these and see how the model performs on this slice of the data. So it really helps me understand better what my model is doing. And it's very important these days to companies when they want to make sure that their model is not like creating biases. So this was my talk. And I'd love to have some questions. Yeah, you. I know you.
Can you use pipelines to do DevOps stuff and not ML?
Definitely. You're just basically running, you're running containers. So your containers can run running coin flipping, and they can run deployment tasks. You can basically run anything.
In your talk, you mentioned that you can have pipelines running on either the cluster or Cloud Data Flow. Now, Cloud Data Flow has a very Java-centric, way of doing things, like you specify your do-FN and all of that stuff. How does one translate? I fail to see how there are payloads that can run. Pipelines that can run I see.
So it's
Because
just
okay, then that makes sense. Okay.
so just an API call.
Is it running behind the scene jobs for completions, or does it run? What does it run underneath in Kubernetes? How does it translate to
Yeah, so
its
you have
Kubernetes object?
So you have a list of pods that are running. Each and every one of these, one of the pods is called the pipelines, and the pipelines is responsible for scheduling other pods that are actually the code that you're running.
So there's no jobs, and that brings up pods.
You're running on top of Knative, but they're not jobs, they're regular things.
Oh, so it's Knative, okay. And also another question: how does it work with ECR, where you have to get the credentials every 12 hours?
I'm not sure about that. I'm more of a
because
machine
there's a
learning
lot of
person.
other open source projects like that, like Polyaxon and stuff like that, that failed to do this specific task.
And what is
to retrieve the images from ECR, because the credentials are getting changed every 12 hours. Does it has anything about this that you know?
No, not sure.
Okay.
So let's say you have like a data pipeline processing that's running in Spark, and you're processing like 1 billion rows or something. Does like that stage then, that billion row processing happen in like a single container? Can you distribute the containers? Like how does that make sense?
Okay, so there are some pods in Kubeflow that are supported natively. For example, distributed training. So if you have machine learning code and you want to run it distributed on the Kubernetes cluster that is actually the Kubeflow cluster, that would be supported. Data processing is not distributed in Kubeflow. So it's either you are bringing your own distribution method onto this cluster, or you're calling a different an outer service. And for example, you can launch a data proc job that does your preprocessing. And what you would do is that you would send, for example, you would tell Dataproc where to search for the data, do the preprocessing, and write the data to cloud storage. And then the next step would be to retrieve this data from cloud storage, and the containers will only pass references to the data between them. So you're not actually bringing the data in this tab. The preprocessing, you're not bringing the data onto the Kubernetes cluster.
Like, sure. So with like from an industry perspective, like Spark's been around for a while. Do you see a movement? Like Spark can get complicated to run and manage and cost. Do you see that movement happening? And as people move to more Kubernetes, aside from services, are you seeing like Spark jobs also start moving this Kubeflow area where you're calling APIs and stuff to do processing and heavy lifting on other systems?
So I know that my field is not really big data. So I do know that Spark is also already integrated with Kubernetes. I'm not sure that, but I'm not sure that you'd have to replace. You'd have to replace Spark, but rather the idea I think it would be wrapping things. So you don't really care today. I've ran some really heavy load Spark jobs on Dataproc. And it's really easy to do, actually, because Dataproc really well manages your Spark cluster. So I think that the way I would work is just using this abstraction called a Dataproc and not really caring about what's going on in the background. But sometimes you do know that like tuning your Spark cluster can like be very tricky. So there are platforms that are there are tools that are replacing Spark and moving towards Kubernetes. But it's not really my field of expertise. I'm more of the machine learning and less of the big data. Yeah. You've already done, so you've got to be serious.
Thank you, Gad. I think it's a great presentation about machine learning. My question is, your earlier slide, you had 1947, the checkers, which was 8 by 8 square, which is like 64 squares, where two players are playing on a kind of closed boundary. we don't have that kind of boundary anymore because we are global now. So actually and then I think later on, IBM came out with a machine which was computing chess game between Kasparov, which is a world champion in thinking, and also all the chess openings, middle games openings. I think today I heard that we had Mr. Pichai came with a computing machine which is using qubits. The qubits are basically a concept of new ways of looking, because if you're doing machine learning, you're dealing with a lot of data. The data becomes very big, and I think the computation, there are delays in terms of, it doesn't have the power to, like how to rotate the cancer cell in biology, or, cosmic events, which are much, much bigger in data. Data is very big. So I think, give me this concept of transition from modern computing machines, the way we are looking at this today, and the next one, which is the machine which has been announced today by Google.
So just to point out the question itself, my perspective on
Machine learning.
But specifically on the impact of computers on machine learning.
Yeah, I think how do we go machine learning from binary computing to two-dimensional qubits computing?
Well, seriously, I have no idea.
You're talking about quantum computing, right?
Yes.
Yeah.
So I think like naturally it's going to affect the same way it's going to affect every other part of every other computer software that you're running. You'd be able to perform more computations per unit of time, then you're going to have better performance, especially in machine learning when you're running a lot of operations to accomplish your task. Then it's just going to boost your ability. I'm not sure it's like specifically like impacting machine learning, but
well,
yeah.
I think there are two sides to it. One is like a computing part, because just like the way Renaissance started was we looked at two eyes, where we were looking all the paintings before 500 years ago. Everything was on a flat screen, and I think this was Renaissance time when we saw 3-dimension. We were looking at two eyes. So I think what my concept is today, we are talking about machine learning, where we have a lot of data, where machine is becoming much powerful than human mind, because it can. I can't remember my brother's name because I've got 8 brothers, but the machine can remember all the guys who are here. So actually, my question is basically the creative part of the brain, which is the other side of the brain, which is like that's where the machine learning comes in, because actually the other part of the brain, it sees all the data, and it's a creative move. Should I move D4 or D5 or queen to this place or that place? That's a creative field. I think this is where the
So you're saying that will induce a more sophisticated way of it would change the theory behind machine learning by simply being able to do some things in parallel, like
right,
like
something parallel, yeah.
Well, I have to say that I failed my quantum physics twice test. So
well, because you're seeing the binary state. The binary mind can't think of the qubit.
So I guess that will have some implications, but I'm too humble to tell you how quantum physics, quantum computation is going to affect machine learning in the near future. There's a lot of good talks about it, but
what's a great presentation for today's sake? It's very good. Thank you.
Yeah, sure. Yeah.
So I wanted to ask, like, before you showed the DSL, and how are we supposed to keep track of the DSL code? Because I saw that in Kubeflow you have the pipelines there in YAML format, right?
Mhm.
And I guess that acts as like source control, or are we supposed to have that separate?
Oh, that's very good. That's a wonderful question. So there are two ways in order for you to actually handle your code versioning. The first one is your code itself. So you're going to use GitHub. So you have the code that does the model processing, the machine learning. You're going to keep it in GitHub.
In this example, will be the flip coin, for example.
Beg your pardon?
In this example, it would be the random that line of
Yeah,
Python
exactly.
code, right?
This line of code, I would keep it in. Well, this one is a very, very simple pipeline that I'm running. It's running an Alpine image. But instead, I could save the code in GitHub and then containerize it and put it in a container repository like GCR. So instead of here building bringing the Alpine image, I'll bring my container for GCR and run it. And the arguments here would not be the code, but rather hyperparameters that are going to input to my container. So two ways to handle your code is one is GitHub, and the other would be to containerize and upload it to your cloud repository.
And the pipeline itself, should that be GitHub as well?
So
in which format?
So when you want to upload, Kubeflow also has an internal way of internal database for your pipelines. So all of your pipelines in the database are presented here. Right. All the pipelines that you're uploading are here, and they're stored in a database. It's kind of tricky there is no support currently for versioning of pipelines. So yeah, you would kind of use, I would use GitHub to keep versions of my pipelines. So the components, I would say, would be saved in GCR. The code would be in GitHub. And my runs of running the pipelines and my measurements are going to be under the experiments stored internally on your cluster. It has a MySQL background running in the background, storing the results of the.
Last question. So, and if you have the requirement of having to work with a known and not moving set of data, so if your data set has to be known, because then it has to be audited or something else.
What do you mean by known?
Like, let's say I'm running a bunch of different tests or algorithm or experiments, I guess, and even changing like different pipelines. But I have a single data set that I have to work with as an input.
Yeah.
How will you go about like tracking that data set?
I would start by actually replying to the opposite question. Sometimes you have a fixed pipeline and you're changing the data. For example, over different periods of time, you want to retrain your data on different periods and just substituting the data set. So you can put in one of the parameters to the pipeline could be a reference to the data set. If you want to use the same data set, then first of all, it's kind of easy. You can tell it always to go to the same location where it's stored and bring it in. But you also have, and this is kind of new in version 0.6, you can bring your data as something that is compatible with a container. You can bring it as an entity under your Kubernetes cluster, and we'll get a volume. It will be stored on your volume, and you can connect this volume to different pipelines. So, what's the name? Persistent volume. Yeah.
Thank you.
How do you, can you go a little bit over the typical workflows from using Jupyter notebooks for a data scientist to then jumping to using the pipelines? I mean, what's typical flows? Like, for example, in Jupyter pipelines, I'm guessing, I'm not a data scientist, you do some experimentation in terms of, let's say you're doing some feature engineering, you decide on certain features, how do you propagate them now to Kubeflow, to a larger data set and so forth?
Okay, so this would be the most painful point, because notebooks are really fun to work with. Do we all know how notebooks look like? So the idea is that let's use the one I launched. So what I'm doing here is I'm launching a notebook, and this could be, and each and every line here is just running Python, and it's really fun to work with it because you see the outputs on the UI. So if I'm like building a data set and I want to make a visualization, I can like see the results just under my code, and it's really comfortable to work with. So for the experimentation part, where I don't know what's going to be the model, I just want to see the data, want to try new things, I would work on the Jupyter. Later, when I kind of have a sense of what I'm doing and I kind of know where the data is coming from and what code do I need to bring on and what's the training that I want to perform, I'm going to kind of sort it all into a GitHub repository. And then I'm going to containerize my code. I try to break it down to specific containers that do very limited work, and then compose it as a pipeline and run the pipelines. So pipeline is kind of after you kind of know where you get the data and what's your machine learning code after you don't change the code.
And is there any tooling that would allow you, for example, let's say that you came up to some final transforms for your features, to, for example, push that into a container? What's happening is in our organization, I mean, we have a data science team that's less technical. So some of these translations we're trying to automate as much as possible, jumping from Jupyter notebooks to the pipelines.
So actually, yes, this is the approach Netflix is taking. They've written a wonderful blog post, I think, about it 2 years ago. And there is a library that enables you to run notebooks as part of your pipeline. And it's supported by Kubeflow. I think Lack from Google also demonstrated. Very, it's called Paper Mill. Show you this. I think it's called. Maybe it's. Not live. This one, 2 chaos on for Lack. No, I know, but it's not funny. So there is this is one. It's the first one. So it's a way, and this is Lack from Google. So he actually has a very good blog post on how to schedule notebooks. So you're actually writing the notebooks. You have to have, you're basically adding input parameters and output parameters for the notebook. And then you could just schedule them using Paper Mill and build a pipeline of notebooks.
This is only part of the solution, but the idea here is that you have different team members who are specialized in areas. So usually when we start to work, hi, my name is Joe, I'm from Do It. And when we'll start to work, God will start to work on the problem. He's the machine learning expert, he's the data science expert. He will start to play with the Jupyter notebook. At some point, he will start to better understand how he needs to massage the data. And then he will come to me or to somebody who knows how to code, and he will ask. And this guy will write crunching the pre-processing the data. While God will write in his notebook the model, how to create a model, what are the inputs, what are the outputs, what he wants to do with the model. But the idea is that you will have different teams. Each one of them will be able to build his container. You will know exactly what are the inputs, what are the outputs, and the brain will be written sometimes by different teams. And this way, you will have the best teams working on exactly what they know how to do, and you will be able to move faster because you have the APIs, you have the graph, you have the DAGs that you find, and you are not dependent on the other team to provide you with the code right now, because you need to know what is going to run and how it's going to run. You don't care if it's running on Kubeflow or on Dataflow or on Spark. You don't care about it. You have a block that's supposed to run. That's it. So this is
And I'm sure you can code.
Thank you. To some extent.
Sorry, I think we're
Out of time.
We will be hanging around if you guys want to grab a drink and continue the conversation, please do. But above all, thank you for making time today. It was great to meet you all, and we hope to talk to you soon.
Still a presentation.
תראה את הלייב.